here is this initial screen that you're faced with, and what I will choose here is to record our session. This will be very important because afterwards we can merge that video recording into our Acqknowledge data. Okay, we can choose the fixation time. So when we look at an object, let's say you look at a cat. So if you look at the object for 1 second, it will be considered a fixation, or we could dial that down to 0.23 seconds. I'll leave it at 1 second so that everybody can follow along. So keep the fixations a bit longer. And we're going to choose an environment, and I'll go into how we actually make this happen later. Now it's just a number of pre-configured environments. Okay, so I'm going to choose this environment, and inside each environment there can be sub-objects, and I can choose which ones will be fixation targets. So I'm choosing the basketball and the soccer ball, and I can make some of these grabbable. As you can see, I've made the laptop grabbable. So using a controller like this, I can grab objects as well, but I won't be grabbing any objects right now, just showing you that this can be done. And then I'll visualize the gaze point so you can see what I'm looking at, and I'll make it extra large. Now the participant is not going to see this, or I will not see this gaze point, but you will, so you can know what I'm looking at. Okay, and now let's enter some information here. So this is the participant information, and let's come up with some random number here for our experiment. And yeah, let's get Acqknowledge onto the other side so you can see how Acqknowledge acquiring data at the same time. And then we begin. So I'm going to put on the head-mounted display. So I'll look at this creature right here, and it's going to smile at me because I looked at it. I'm going to look at it again. It's going to smile at me again. Now these chickens, they'll react to my gaze as well. So they're quite happy that I'm looking at them. They're jumping up and down. We can look around in the room. We have all sorts of objects here. So here we have a soccer ball. We'll fixate on it. We have a basketball. Look at the soccer ball as well. And then we'll look at the chicken right above it. That's sufficient for our purposes. So I'm just going to get out of it right now. I'll press space bar so it stops the recording, and it also stops Acqknowledge. Okay, now one thing that happens right away is you get this report generated. So we have a number of objects here in the room. We have little chickens, we have the creature, and basketball and soccer ball. So we can look at some basic analytical information. So total view time and average fixation time. We can see we never looked at 2 of the chickens, which is why they never moved. So this is also generated as a PDF. So right now I'm just going to close it. So okay, let's auto scale the data. Now you can see all these markers were coming in. So we looked at the creature, we looked at the creature again, the chick, soccer ball, etc. So all of these are markers that came in over the network from the virtual reality component of the system, from the Wizard software. Okay, so now something else we can do is we can link up media. So we'll come over here, and we're going to look for the file that was generated. So that's the one. Okay, and so I'm going to place it like somewhere here. Actually, let's have these side by side like that. Okay, there we go. And here are our events. So now here we are looking at the creature. I can make this a little bit bigger so you can see it better. So here we're looking at the creature. We can play it back so we can see we looked at it and it smiles. And then I looked at it again, and then it smiles again. So the video is linked with the physiological data. You can click on like the soccer ball, for example. You can see the soccer ball right here. I'm looking at the soccer ball. So it's very useful. Everything's linked together. Now, since we got all this information in real time about when we looked at the various objects, and here we can see the descriptors, we can perform some analysis in Acqknowledge. So here we have some ECG, and by the way, I'm not connected right now. There's just too many things going on right now to be connected. I use Acqknowledge in playback mode, which is extremely useful for when you're testing, when you're preparing an experiment. You can actually play back data and make it look like the real thing. All right, so we'll go to analysis, find rate, and we're gonna base this off the ECG. So this is just heart rate from ECG, human resting heart rate. Let's give it a bit more of a tolerance. Okay, and now we're gonna end up with a new waveform here on the bottom, which is the heart rate. Okay, so let's hide the other one. So here's our heart rate. And I can very quickly generate some useful analysis. So I can say, let's do a stimulation response analysis. At each stimulus event, I want to grab the next 3 seconds. And this would differ depending on what you're doing. Is it electrodermal activity, heart rate, etc.? So a bit arbitrary right now, just showing you how it works. So at each stimulus event, I'm going to get the mean. Actually, I want to get the rate mean of the heart rate channel. And yeah, let's just go ahead and get this into an Excel spreadsheet. So now we have here for the creature, we can see 2 times that we looked at it 2 times, and now we have the heart rate. Then we have for the chicken, we have it for the soccer ball, etc. So this could be a number of different physiological parameters that you're requiring. And since you have the data for fixations, then you can perform this analysis. There's also automatically this data a folder that gets updated. So this is the PDF. Okay, the PDF that I showed you initially. Okay, so that's there. Now, in addition to that, we have the tracking data. So the tracking data, it shows us XYZ and also gives us the pupil diameter. Okay, and when relevant, it also provides information on, there we go here, on when we have looked at a new fixation. So this, for example, this pupil diameter information, this is just the text format. So we can bring that right into Acqknowledge, and it can become another channel in Acqknowledge. Okay. Something else that we can do is now we can come back to the virtual reality software to Wizard, and we can replay our session. So let's just hit here. Okay, and we're going to use the desktop, but we could view it inside a head-mounted display, but I'll use desktop mode. Let's click OK. And our participant ID, as you can see, I've been very creative here with my numbering of participants. Is 3333. So here we are looking at the same scene. And if we click to static, we can see our entire gaze path, for the whole experiment. If I move here, you can inspect things a little bit closer. Okay, now I can go to dynamic. And if I go to dynamic, it's actually going to play back what happened during the experiment. So let's just press spacebar, so visualizing it. Okay, so this is my avatar looking at stuff. So okay, looking at this creature, looking at the creature again. Okay, looking at the other chicken and so forth. Okay, let's pause that. So a lot of different things you can configure here, and the pupil diameter is shown right here. So it's also provided here. A lot of choice these days for getting 3D models, and I just bought the 3D models and there's also a lot of free ones on Sketchfab. So Sketchfab has a tremendous number of 3D models out there. So here's the creature. So if we look at the creature here, yeah, it has a number of different animations. And I just downloaded the GLTF format. That's the format you want to make it work with Wizard. So you need the GLTF format. So in fact, all of these things are just without any additional work. Just get them from the web. Like the room here, that's also just the 3D models. I did not actually create any 3D models. I just got the 3D models. And I placed them in a folder called, let's go to our resources. So this is basically the structure of the SightLab. That's the eye tracking analytics lab. So you have this folder called resources, and there we have environments. Okay, so now here is the environment. Okay, so that's just that model in the experiment. So and you can do things like resize objects, rename them, etc. But I'll show you what I did do. So if you click here on one of the objects, for instance, here we have the basketball. Okay, initially it wasn't called basketball, so there was no way for, we had to tell the program somehow that this is an object that should be tracked in the program. So for instance, okay, here we have an object. Okay, here we have a bunch of these objects. Let's just see what else we can find. Okay, so here we have the TV. Okay, so that's the TV object. So to make this an object that is used in the eye tracking, we can just come over here and say insert above and make it a group, and then we rename it, and we just call it TV. All right, so that's all we have to do, and then I'm just going to save. I'm going to save this just over the old model. So now there's an object here called TV. So with this information, it will now be in the list of objects that can be tracked. So let's just verify that. So we'll come back over here, and we have the main program here for the 3D scenes. So just execute it again. This time I'll use it in desktop mode. Okay, so we're not going to record anything. I just want to click here on configure, and now you see we have a TV, and we can make it a fixation region or not. So that's basically how easy it is. So if you don't want to, or you can't program, you can just get a 3D model, and you can name parts of it, and they will become accessible. So you can set these as up as targets to track. You can even add additional objects. So see, there's a bunch of objects already included, but you can download more from the internet. Like I'll just add a chair. So here's a chair. Okay, now this chair will also become an object that can be tracked. Okay, so here's our chair, and we can do things to the chair. So we can move it around. So in the world, we can reposition it. We can change its size. Maybe we want it to be really small and see how people react. Okay, so and you just place these objects into the objects folder. Okay, so you can make your own or download from the internet. The reality is everybody's just downloading things from the internet these days, because let's just have a look here. Let's look for chair and downloadable models of chairs. So there's so many chairs. A bunch of them are free, some of them are paid, but there's a lot of objects out there that you can just use. Okay, and so basically that's how it works. So you can just use it as is. You can get 3D models and just perform an eye tracking experiment. But if you want to interact with the environment, you can get into the code and you can start making changes. And because the functions are, nicely named, and there is also extensive documentation that tells you exactly what to do, it's really not that difficult. Okay, now I want to show you something else, another analysis tool that's part of the eye tracking analytics. It's a heat map. So now this is a replay of what the participant has done. Now, I want to show another example here. And just say a few words first of all. Now, traditionally, when you're doing experiments with eye tracking, and maybe you're presenting something in front of a computer for 2D images, well, we can really evolve this a step further in virtual reality. Like you can walk around, physically walk around, or move around in a gallery where you have images, for example. And now I'm going to have fixation regions. So when I'm looking at parts of that space, instead of objects, this time there will be regions of the space that will be subject to eye tracking analytics. Let's just begin. Okay, so here I am now in the world. So I'm looking around, and so now I can look at different parts of the world, and there's different there's different objects in here. Okay, and I can also move around in the world. I can navigate this world, just go to a different place, look at the artwork. So come over here, and I've set these up as tracking areas. So I can actually track them. So even though they're not 3D objects, let's stop here, and now let's have a look. We have some data for where we've looked. Okay, one of the things I wanted to track was this. Okay, so how did I do that? Well, I've added these objects. Like right here, we have an object, but it's transparent. It's an object that is right there. And then if we turn around here, so here is the Brittany one, and there is another object. Okay, it's like right here is the object you can see, but it's transparent. Actually, we can make it not transparent by changing its alpha. This makes it easy to reposition the object. So I can move it to a different place. Okay, and that object is originally inserted by just going to add, and then you go to the default objects, and there is fixation region. And I also want to show you now how to work with 360 images and videos. So if we come over to resources, media, I've downloaded an image here. So that's just a 360 image. I don't have to put on the HMD anymore for you to get the idea that it works with an HMD. So desktop mode. And again, we can do a recording, and we have to say, is it a video or is it an image? Is it mono or is it stereo? And then we choose what it is. Okay, and so let's continue. And here we would put in our subject information, but I will not do it right now. So here is the scene, and if we look at the house, you can see it says gaze fixed on the house. Okay, and then gaze fixed on the peak. And now we have gaze fixed on the grass, and here's our gaze path at the end. So there's very clear instructions. So if we look into the documentation, these are the documentation. So you can see here. So if we just look for 360, okay, so fixation areas for 360 images and videos, there are instructions you can just follow. And it's the same with all the other things that I showed you. It's all described in the manual. So what about adding physiological measurements? We already did a demonstration for what it would look like if you had our MP160 system connected. So with our MP160 system, you can connect many different physiological signals. I'm going to concentrate on a few common ones that come up in the context of VR. So let's look at stress, for example. All these different stress-related measurements and related to many other psychological function as well. So in addition to that, you can record functional near infrared. You can see here our functional near infrared. This is a sensor functional for the functional near infrared systems. It's very thin, and as you can see, it fits under the head-mounted display under this one right here, for example, the HP Omnicept. We have this full integration between the physiological data acquisition and the virtual reality components.
Available now from WorldViz. To learn more, visit www.worldviz.com or contact sales@worldviz.com.